In Chapter 7, we study the adjoint operator and properties of the adjoint. And this is closely related to ideas of duality that we saw earlier. And once again, the adjoint is an operator that's defined by a sentence almost more than a formula. It works like this. Suppose we have a linear map from V to W. Then the adjoint of T is the map denoted by T star, which goes in the opposite direction. So it goes from W to V. And it's defined to be the thing that you put in this slot of the inner product, which makes this identity hold for all V and W, all V and V and W and W. Now, it's not immediately clear that it should be possible to do this. Like, how can you use this to define T star? It actually is leveraging the Rees representation theorem. So let's see. To see that this makes sense, suppose that we, for the moment, fix W, right? Then W and T together define a linear functional let's call it phi. So phi of V is going to be defined by, we take V and map it by T, and then we take the inner product against W. Okay, so as V varies, this is going to spit out a number, and you can see that it's going to be linear because T is linear and the inner product is linear. So this gives us a linear functional defined on elements V. Okay, so then we know that phi of V is given by the inner product of V against U for some fixed U in V, and this U is going to, or at least phi is going to depend on W and T. And we know that phi is given by an inner product of this form by the Rees representation theorem. Right? Okay, so we define T star of W to be U. And so it's a bit clunky, but if you work through it, you'll see that this actually does define a mapping on W, a mapping from W to V, in fact, because notice that the W started in capital W, and this U that we get that gives us the functional comes from V. So this gives us a map that goes from W to V. All right. And so just to sort of diagram this out a little bit, here we have V, here we have W. T is a mapping that goes this way. T star is a mapping that comes back this way. And when we look at the setup here, so we've got TVW, notice that this is the inner product here is the inner product in W. So I could put like a little subscript W on here if I wanted to, just to denote that maybe. And then on the other side, the thing that we're looking at, V is an element of V, and T star W maps elements from W back into V. So in fact, this one here, this is an inner product computed on elements in V. So maybe I'll put a little subscript V here to indicate that. And I'm not going to go into it too much right here, but it's worth noticing, and it turns out to be super important in other courses, is that the adjoint operator also makes sense in the infinite dimensional case.